This is a message for Nature Boy about one of the videos he made asking the question, what can you do without a body? I'm going to answer that question. But first and foremost, I would like to say I'm a vegan. I've been a vegan for over 7 years. I work out, I don't drink or smoke. I'm trying to take good care of my body and mind to the best of my ability. I would never harm another living creature unless it's trying to harm me. I don't condone cruelty to animals. That's going to be in some parts of this video. I'm going to answer your question with proof and evidence. This is not a hate video. You proposed a question and you are making some bold statements. And I'm simply either going to answer the question or respond to the bold statements. That's all I'm doing.
You on? Live? Yep. Alright, good. Everybody share it? So I asked a question to everybody online. I wanted to share, everybody asked a question. What can you do? Name me one thing you can do without your body. And, we got some good comments, and I wanted to address them because people were just blotting stuff out real quick, and I want to address each one you're gonna tell me one thing you can do without your body, and I'm gonna attempt to show you how you are actually using your body to do that. And so the question stands: name me one thing you can do without your body, and I prove that you're doing it with your body.
And here we are in the Brain Research Laboratory. Yeah, here's the brain when it was stored.
Dr. Robert White is a neurosurgeon at the Cleveland Medical Hospital in Ohio.
Now, here are some pictures.
In 1963, he performed the first experiment to keep a brain alive outside the body.
That's the human skull here. That's not real. This is a gorilla. See here, when you take the brain out and isolate it, you can take all that if you want, and you keep it alive and live forever. See, this is a human brain actually, and it is fixed, so no one needs to worry about it being alive. There have been many attempts throughout the world, particularly in the old Soviet Union, to take the brain out of an animal, they like the dog, for example, and keep it alive with machinery. Now, you can do that with the heart, the kidney, the liver, the lung, all the other body organs, solid organs. But nobody had ever been able to do it with the brain. And part of the reason is we must remember the brain is very delicate when it comes to its blood supply. And so when we finally did it and found that this brain of a highly developed animal had brain waves, had biochemistry, was functioning just as it would. Now, we couldn't talk to it, we could send it electrical signals, we could show that it could actually hear and so forth, but we didn't know whether it was processing the information. But the point of it all is that that moment in time also said to us, if you can do it for the animal brain, you could do it for the human brain.
To prove that the brain was in fact functioning normally while in this state, Dr. White needed to undertake a second experiment, during which he succeeded in transplanting the head of a monkey onto the body of another. The creature survived for 7 days before the body rejected the head.
In the monkey experiments, these animals are as much a monkey as they were when they were in their own original body. So I would presume, and I'd go beyond that, I would be assured that the monkey personality is retained. So consciousness can be transplanted. Obviously, personality, if you want to speak of the monkey having personality, can be transferred. And so you might ask, where did this bring us as far as the human spirit or soul goes? And I guess you could argue it can be transplanted. Had brain waves. At biochemistry was functioning just as it would. Now, we couldn't talk to it. We could send it electrical signals. We could show that it could actually hear and so forth, but we didn't know whether it was processing the information.
What Dr. DeMars has done is got the neurons in this dish to think. That's right. No one has told them how to fly a plane. They've worked it out by themselves.
He wanted to push neuron research beyond anything that had ever been attempted before.
The neurons really make up the primary computing unit of any brain, both our brains and in animals.
What's coming next? Watch the signals on the monitor carefully, and you can actually see the neurons in action.
These spikes that you see coming off that waveform are literally produced by those neurons. When they fire their message, it's an electrical event.
The output from the brain, which we can pick up as electrical signals on different electrodes, drives the wheels of the robot.
Connection 3 shows that it is possible to create a direct brain-machine interface, the holy grail of hybrid robot design.
Electrical current flows through our nerve cells, the neurons, carrying instructions and information. That same current can flow to and from the cells into man-made devices, allowing them to communicate and interact, setting the stage for some remarkable developments. What if you could go one step further? To receive impulses coming out of the body, to read thoughts and intentions coming from the brain itself. Igor Feynman is a neurosurgeon who works with patients who have lost the ability to move, who are trapped inside their bodies.
One of the first things that we'll be able to do is letting somebody who is completely locked in, say, get on the web and use a cursor on the web, and just by their thoughts move the cursor on the web and surf the internet or something like that.
The centerpiece of this revolutionary new project is a brain implant that will actually read out a person's thoughts directly into a computer. The project is headed by Dr. Richard Anderson, a neuroscientist from the California Institute of Technology. Anderson discovered a special region of the brain where movements are thought up and planned in the split second before the body carries them out. It's called the parietal reach region. Using brain imaging systems, Dr. Anderson and colleagues have shown that this part of the brain still functions even in those who are completely paralyzed. Working with a team from NASA's Jet Propulsion Laboratory, Anderson is designing a computer chip that can be placed into this region. The chip has a series of electrodes that plug right into the brain tissue and pick up impulses given off by brain cells. It will relay those impulses to an external computer. It's the ultimate remote control. Users will merely think about an action, and it will happen. They'll imagine reaching, and their neurons will send the command to a robotic arm or a cursor on a computer screen. In short, the implant will allow the mind to act directly on the physical world around it. A kind of high-tech telekinesis, connecting the flow of electricity in the brain to the world of computers and man-made devices. In this age of advancing technology, we are becoming increasingly impatient with the bodies nature has given us. With our frailties, our failing sight, our broken limbs, the crippling limitations of illness and age. While our minds soar, our bodies seem frozen in time. What if we could build a better body? Use technology to fix this human form, and then actually improve upon it. Make it stronger, faster, smarter, and create the human of the future today.